Solving quadratic inequalities. We are going to start with the type 1 quadratics with two x-intercepts. So here is an example. Solve the quadratic inequality x squared minus 2x minus 8 greater than or equal to 0. First, we are going to calculate the x-intercepts of the function y equals x squared minus 2x minus 8. For this, we are going to let y equal 0. This means that x squared minus 2x minus 8 equals 0. Let's factorize this. Remember, we need two numbers that multiply to negative 8 and add up to negative 2. And these two numbers are 2 and negative 4. So now we can write the product of the two factors. X plus 2, x minus 4 equals 0. Using the Null Factor Law, we can say that x plus 2 equals 0 or x minus 4 equals 0. We solve the two linear equations, so x equals negative 2 or x equals 4. So here are the two x-intercepts. Then we are going to sketch the graph of the function y equals x squared minus 2x minus 8. We only need the x-axis because we only need the x-intercepts, negative 2, 0, and 4, 0. Now, this is a positive parabola, so it's a smiley one, opens upwards. We can now solve the quadratic inequality x squared minus 2x minus 8 greater than or equal to 0. So we are going to look at the branches above the x-axis where y is positive. Therefore, x is an element of negative infinity to negative 2 union 4 infinity. The square brackets are there because of the equal sign, greater than or equal to. We can also write this as x less than or equal to negative 2 or x greater than or equal to 4. Here is another example. Solve the quadratic inequality x squared minus 2x minus 8 less than 0. So we can clearly see that x is an element of negative 2 to 4. Notice the round brackets, and that is because we have less than. There is no equal sign. This can also be written as negative 2 less than x less than 4. Here is another example. Solve the quadratic inequality negative 2x squared minus 9x plus 5 less than 0. So we start by calculating the x-intercepts of the function y equals negative 2x squared minus 9x plus 5. Again, we let y equals 0, which means that negative 2x squared minus 9x plus 5 equals 0. Let's factorize. I like to take the negative outside, so the quadratic inside the brackets is going to be positive. Now, we need two terms that multiply to 2x squared, and that is 2x and x. We now need two numbers that multiply to negative 5. Negative 1, 5, 1, negative 5, negative 5 and 1, and 5, negative 1. Let's start with the first set, which is negative 1 and 5. We multiply 2x by 5, that is 10x, and then we multiply negative 1 by x, that is negative x. So 10x minus x equals 9x. We were lucky that the first set of values worked straight away. We can now use the Null Factor Law. So 2x minus 1 equals 0 or x plus 5 equals 0. Solving the two linear equations, x equals a half or x equals negative 5. So we can sketch the graph of the function y equals negative 2x squared minus 9x plus 5. All we need again is the x-axis with the two x-intercepts. This is a negative parabola, so it's a frowny face. It's an upside-down parabola. We can now solve the quadratic inequality, negative 2x squared minus 9x plus 5 less than 0. That is, x is an element of negative 8 minus 5 union a half infinity. Notice the round brackets because the sign is less than, there is no equal sign. We can also write this as x less than -5 or x greater than a half. Let's look at type 2, quadratics with only one x-intercept. Consider the function y equals x squared minus 2x plus 1. Notice that there is only one intercept with coordinates 1 and 0. Therefore, x squared minus 2x plus 1 is greater than 0 for all real values of x except 1. For a negative parabola, the same thing happens, but this time the quadratic is negative x squared plus 2x minus 1 is less than 0 for all real values of x except 1. We are now going to look at the type 3 quadratics with no x-intercepts. So for example, y equals x squared minus x plus 1 has no x-intercepts. The whole parabola is above the x-axis, which means that x squared minus x plus 1 is greater than 0 for all real values of x. Similarly, for a negative parabola, y equals negative x squared plus x minus 1, this is going to be negative for all real values of x.